Okay, so now that we have some nomenclature down, we can tell some stories about chemicals. And that's what they're giving us here. They write out a description in English, and we have to translate this into a chemical reaction. That those are always going to have an arrow in the middle, and to the left of the arrow is the things that were there before the reaction, and after the arrow is the things that were there after. And we just have to interpret all these names that they're giving us. Here they say nitrogen combines with oxygen to form dinitrogen monoxide. So we start with nitrogen and oxygen, and they combine, and we have dinitrogen monoxide afterwards. So nitrogen is N, but it's one of the diatomic elements. So whenever they say nitrogen, we actually write N2. Nitrogen atoms are found in pairs. And that reacts with oxygen, which is also diatomic. So here we write O2. That's nitrogen meets oxygen. And then chemistry happens. And when that's over, we have dinitrogen monoxide. Dinitrogen means N2. Monoxide means one oxygen. So that's the finished reaction there. Not too bad. Phosphorus reacts with oxygen. And it doesn't matter if they say combines or reacts. There's a number of words that do the same job there. These two things combine, and afterwards we have the product diphosphorus pentaoxide. So phosphorus, hopefully you have it on your table, is P4. This is something you would have had to add in manually, but natural phosphorus is usually P4. That reacts with oxygen, which is O2. And we get diphosphorus means P2. And pentaoxide means 5 oxygens, so O5. Okay. Calcium reacts with chlorine. And they don't say the products, so I guess we get to work those out. Calcium is a metal, Ca. It's not diatomic, but chlorine is, so we get Cl2. And what happens when they combine? Well, this is a metal and a nonmetal, so there's going to be one positive and negative ion. We can use what we know about ionic compounds to figure this out. Calcium ions are Ca2 plus, always, and chlorine ions are Cl minus, always. So it's going to take two chlorines to match a single calcium, and that means the product is going to be CaCl2, or in English we'd call it calcium chloride. Now, all three of these are what we call formation reactions, or sometimes synthesis reactions, where you put some pieces together and you make one thing out of them. We can also go the other way, where you start with one thing and it breaks into pieces, and that's what this fourth one is. We start with ammonia, NH3, and it's going to break apart into its elements, which are N and H. Nitrogen and hydrogen. But now that these are alone, we don't care what numbers they had when they were part of ammonia. We care about what numbers do nitrogen and hydrogen have when they're by themselves. Nitrogen is a diatomic gas, so it will turn into N2. And hydrogen is a diatomic gas, it will turn into H2. These numbers have nothing to do with NH3. We just look at this to see, okay, we need N's and we need H's. The 2's here come from what we know on our periodic table about the fact that these elements are both polyatomics. What else have they got for us? Silicon reacts with fluorine to produce silicon tetrafluoride. Okay, well, silicon is Si, and it's not polyatomic. You find it as just Si. It reacts with fluorine. Fluorine's diatomic, so its symbol is F2 when it's by itself. And when they combine, we get silicon tetrafluoride, which means a single silicon with 4 fluorines, SiF4. Iron 3 oxide decomposes into its elements. Well, we have to write a formula for iron 3 oxide, and if we don't know what that is, then we have some math to do. Iron 3 means this. Oxides are -2. So how do we get those charges to match? 3 and 2, it looks like we're doing the 6 thing. We're going to need 2 irons. That'll give us +6 charge from the iron. And if we have 3 oxide ions, that'll give us -6 there. So +6, -6, we're good. That means our formula is Fe2O3. That's iron 3 oxide. Now they say it falls apart into its elements. So we start with iron 3 oxide, and it breaks down into whatever Fe is when it's by itself, and whatever O is when it's by itself. Sorry, that looks like a 6. I can't stand it. Oh, okay. Now, iron is a metal. They're all monatomic. For those you just write the symbol, and you never have to write a 2 or a 5 or anything like that. Iron is a standalone. Oxygen, however, is a diatomic gas, so whenever they say oxygen, or whenever oxygen comes out of a reaction, we have to write O2. And that'll do it for that one. Okay. So far, when they've said decomposes, they've always said into its elements, and so we've just done, this is made of iron and it's made of oxygen, and that's it. Here, they say decomposes, but then they take charge and they tell us what it breaks down into. This one does not break down into just its elements. We start with sulfur trioxide. That means a single sulfur with 3 oxygens. And then it breaks apart and they say we get sulfur dioxide, which is a sulfur with 2 oxygens. And then plain old oxygen, which is O2. So if they just said sulfur trioxide decomposes, I would have written sulfur as, here, I'll do that as a hypothetical. If they just started us with SO3 and they just said decomposes into its elements, we'd write S and we'd write O. Sulfur by itself is actually S8, and oxygen by itself is O2. So if they just said decomposes, we would have done this. But because they specifically said sulfur dioxide and oxygen, we just follow what we're told. And last one, hydrogen carbonate. That's a polyatomic. Carbonate, you will find on your periodic table in the polyatomic ion list, it's CO3 2-, and hydrogen ions are normally +1s. So hydrogen carbonate requires 2 of these, and it is H2CO3, right? 2 hydrogens to match the charge on a single carbonate ion. And then they tell us that breaks down into, if they said elements, we'd have to write H and C and O all separately. But they're telling us it breaks down into water, and we know what that is, and carbon dioxide, which means a carbon and 2 oxygens. Good.